Olá a todos, bem-vindos a mais um vídeo do canal Desmistificador de Cripto. Se você é novo nesse canal, não se esqueça de você estar se inscrevendo, ative o sininho das notificações e compartilhe com seus amigos que gostariam de estar aprendendo aí a investir no mercado de criptomoedas. Galera, sem delongas, no vídeo de hoje eu vou estar mostrando a vocês mais um airdrop totalmente fresquinho e novo aí pra gente poder estar ganhando tokens do projeto, tá? O projeto de hoje a gente vai estar falando vai ser a respeito da DAM, né? Tanto do projeto da DAM quanto em parceria com o projeto da Andrena. No caso, a gente vai estar utilizando o projeto da DAM, né? A acumulação de pontos, e a gente vai receber os tokens da Andrena, né? Eu vou explicar aqui putitim como é que vai funcionar esse airdrop, tá? Basicamente, galera, esse projeto aqui da DAM, ele é um projeto que ele é voltado diretamente para uma rede wireless autônoma de forma descentralizada, tá? Então, como vocês podem estar vendo aqui dentro do site, já tem a informação pra gente de que é uma rede totalmente descentralizada, né? E aqui tem a informação de que a gente pode estar ganhando por estar compartilhando a nossa internet diretamente à infraestrutura, tá? Eu vou estar explicando só um pouquinho a respeito desse projeto, mas eu não vou me estender. Por quê? Porque no final desse vídeo aqui eu vou deixar um corte do podcast, na qual o CEO do projeto, ele participou e ele mesmo explicou como é que vai funcionar esse projeto, tá, galera? Então, deixem aí o like de vocês, né? No caso, o CEO do projeto é o Neil Chatterjee, né? É o nome dele. E aí, galera, o que é o foco, no caso aqui do projeto da DAN, né? Aqui a gente já consegue ver algumas informações que eles deixam até aqui pra gente, né? A gente pode até colocar aqui, vou colocar em português para vocês possam estar lendo também juntamente comigo. Aqui tem a informação, né, dizendo que a DAN é uma rede sem fio totalmente descentralizada, né, para poder fazer o fornecimento de serviço de internet, tá? E aí eles vão utilizar aí um protocolo na qual vai ser o próprio DAN, né, que é o protocolo do projeto em si, e eles vão estar utilizando aí o segmento de hardware, né? No caso, proprietários ou moradores que tenham a oportunidade de estar comprando e vendendo a capacidade de internet na área ao seu redor, né? Capacitando os usuários a operar como seus próprios provedores de internet, né? E aí também vai ter a parte da natureza descentralizada do projeto DAN, né? Que vai estar facilitando aí um sistema de troca sem confiança que emprega a prova de Baku, tá? E no caso é a localização e frequência. Então como é que vai funcionar isso daqui? A gente tem o Whitepaper aqui do projeto, vocês acessando aqui o site da DAN, vocês podem estar acessando o Whitepaper do projeto. Aqui também a gente tem informações dos parceiros, né? Esse projeto aqui, ele recebeu a arrecadação inicial de 18 milhões, tá, de dólares. Então, galera, essas empresas aqui, essas Ventures Capital que vocês estão vendo aqui na tela, são algumas das empresas na qual investiu nesse projeto, tá? Então a gente tem a Robot Ventures, né? Dentre todas essas outras empresas aqui, né? Essas empresas aqui são empresas conhecidas no mercado. Principalmente a Dragonfly, a Robot Ventures e a Fictionless Capital, né? São as mais conhecidas aí. Aqui embaixo a gente também consegue estar visualizando aqui, ó. Aqui vai ter alguns links importantes para vocês estarem acessando, né? Vocês podem ler como é que funciona o sistema validador, né? Como que funciona o projeto. E aqui a gente também tem o Whitepaper, né? Na qual o Whitepaper é este aqui, tá? Vocês vão abrir. Aqui vai ter as principais pessoas que estão participando desse projeto. Vocês conseguem também verificar aí o perfil deles, né? Apesar de que eu achei um pouco estranho, né, quando eu fui olhar o perfil, porque alguns deles têm, no caso, por exemplo, do Neil, né? O Neil, ele tem um nome que é de se eu não me engano, é um ex-advogado dos Estados Unidos. Eu achei meio estranho, né? Eu achei que poderia ser pessoas que estão se passando por outras pessoas, mas aí eu fui dar realmente uma verificada e eu vi que são pessoas legítimas, tá? Estão por detrás desse projeto. Alguns outros aqui do pessoal, eles são indianos, né, que participam aqui do projeto. Já o Neil, pelo que eu olhei, ele parece ser dos Estados Unidos. Aqui a gente tem introdução de informação, né, de como é que vai funcionar, né, o Whitepaper, tudinho. Aqui tem a parte da introdução, vocês podem estar lendo. Tem aqui a parte de como é que vai funcionar a parte da rede, né. Eu vou mostrar aqui a parte do Whitepaper em português para que vocês possam ler um pouquinho, né. Então aqui a gente tem a visão da introdução, né. Aqui tem mais informações de como é que vai funcionar a capacidade da rede, né? Então aqui ele já diz que a capacidade da rede vai ser multi-gigabit, né? Com formação de feixe mecânico, com amplos espectros não licenciados de alta frequência e assim por diante. Vocês podem estar dando uma lida no Whitepaper aqui depois quando vocês quiserem, tá? Explica tudo completamente como é que vai funcionar a rede, tá? Isso daqui vai dar um pouco de trabalho, tá, galera? Poder fazer esse tipo de rede, tá? Porque esse tipo de redes que eles querem fazer, que é uma rede sem fio, ela é uma rede WAN, né? Então, para você poder estar desenvolvendo aí uma rede WAN da forma que eles querem fazer e de forma totalmente descentralizada, eles vão precisar aí de muito mais investimento e vão precisar de bastante equipamentos, tá? Eles vão precisarem aí de diversos backbones para poder eles estarem conseguindo subir essas redes por diversas partes do país, né? E isso vai dar muito trabalho, né, para poder fazer a criação. Mas esse projeto aqui é um baita de um projeto, então vale muito a pena vocês virem aqui, dar uma lida no Whitepaper, os equipamentos que eles vão utilizar, né, como é que vai funcionar tudo certinho. Aqui no Whitepaper vocês conseguem ler tudinho, tá? E eu também vou estar deixando no final deste vídeo a explicação do próprio céu do projeto, que ele explica tintim por tintim como é que vai funcionar o projeto em si também, tá? Então, sem mais delongas, né, pra gente estar finalizando também, a gente também tem um site aqui da Andrena. A Andrena vai ser uma das empresas parceiras nesse projeto, tá? Então, eles vão ser parceiro do projeto da Dan e eles vão estar ajudando aí nessa parte da distribuição da internet, né, da compra e da venda da internet. Então, sem mais delongas, vamos para o que interessa. Então, como é que a gente vai estar participando do airdrop, né? Bom, galera, pra gente poder participar do airdrop é muito simples, tá? Primeira coisa, aqui no site do projeto, a gente vai clicar aqui em baixar a extensão e a gente vai ser redirecionado para cá, para a Chrome Web Store, tá? Vocês sendo redirecionado para cá, vocês simplesmente vão clicar no botão aqui para poder baixar a extensão. Baixando a extensão do navegador, vocês vão clicar sobre ela e aí vocês vão clicar em continuar e vão clicar aqui embaixo no botão de se registrar, tá? Aqui vocês vão colocar o nome de vocês, o e-mail de vocês, vocês vão registrar uma senha e vão repetir a senha e vocês vão colocar o código de referência aqui embaixo para vocês ganharem pontos, tá? Esse código de referência eu vou estar deixando na descrição do vídeo e também no comentário fixado. Fez isso, vocês simplesmente vão clicar no botão de criar a conta, vocês vão receber um e-mail de verificação aí no e-mail de vocês e vocês simplesmente vão clicar no botão para poder validar o registro da conta de vocês. Fez isso, agora vocês simplesmente vão voltar aqui na extensão e vão vir aqui na aba de login, tá? Vocês vão clicar em continuar, vocês vão vir aqui na aba de login e aí vocês vão colocar o e-mail de vocês e a senha que vocês cadastraram, tá? Após vocês fazerem o login na conta de vocês, vocês vão estar vindo aqui, né, nessa tela inicial, tá? E aí vocês vão simplesmente se deparar aqui com pontuação que vocês vão ter. Vocês vão ganhar certa quantidade de pontos utilizando o código que vai estar na descrição do vídeo. E aqui vocês vão conseguir ver a qualidade aí da internet de vocês, que vocês estão conseguindo compartilhar da internet ociosa de vocês, tá? E aqui vocês vão ter outras tarefas para fazer, na qual são essas 3 tarefas aqui. Que na qual vocês seguirem o Twitter do projeto, para vocês ganharem 5.000 pontos. E também tem a opção para vocês irem até ao Discord do projeto, vocês também vão ganhar mais 5.000 pontos, e também para vocês entrarem lá no Telegram do projeto, tá? E galera, esse projeto aqui eu fiz uma verificação bem antes de trazer para vocês, tá? Então eu fiz a verificação do código fonte, eu fiz a verificação de quem é a equipe por trás do projeto, tá? Então a gente tem informações claras a respeito do que o projeto eles coletam de informações a respeito da gente, né? No qual são informações como seu nome, seu endereço de IP, né? E eles pegam a sua internet ociosa e eles fazem o compartilhamento, né? Por trás aí do projeto para poder fazer a venda e a troca, para poder haver a rede de forma descentralizada. E também a gente sabe quem é o pessoal que está por trás da equipe do projeto. Após esse vídeo aqui, após esse vídeo, vocês vão estar vendo um podcast na qual o CEO do projeto, ele participou, tá? E ele mesmo explicou como é que vai ser o funcionamento aí desse projeto. E a gente também tem grandes empresas, né? Grandes VCs que está investindo nesse projeto, tá? Então é um projeto totalmente transparente aí com todas as pessoas que quiserem estar participando, tanto pessoas que forem investir no projeto, tanto quanto pessoas que querem estar participando do airdrop. Então galera, esse daqui foi mais um vídeo aí bem rápido e fácil aí de explicar a vocês como é que vocês podem estar participando do airdrop. E aí vocês simplesmente só precisam deixar a extensão aí configurada na aba do navegador de vocês, e vocês vão estar compartilhando a internet ociosa que vocês não estiverem utilizando durante aí o dia, tá? Enquanto o computador estiver ligado. Eu espero que vocês tenham gostado desse vídeo e fiquem aí com a explicação do projeto, na qual o CEO ele explicou em um podcast, tá? Até o próximo vídeo, galera.
I can speak to that because I think that's what you've described as a thesis that I've long had. And I think, decentralized physical infrastructure networks, or this category of DPIN, is a very fascinating one because ultimately it just speaks to a trend that we've already seen happen in the Web 2 ecosystem. So I guess the parts that I can kind of speak to at least are on the internet infrastructure, namely cloud and telecom side of things. And this entire initiative of I think what everybody in the DPIN ecosystem believes is there's kind of this shared vision. And the shared vision is what's the end state of DPIN? And in my mind, the end state of DPIN is essentially allowing the end household or end user to provide a meaningful contribution to cloud plus telecom infrastructure, right? Whether it's, compute, storage, bandwidth, right? This is what, the escape velocity folks are always talking about will be commoditized in the future. The end state that everybody in the DPIN ecosystem is pushing towards is one where those resources are actually controlled and provided by the end user in the household.
How are you?
Good, man.
Perhaps we can maybe just start off on a little bit of your background, kind of your electrical engineering journey at Princeton, and get into Andrena, and then start talking more about the actual product side.
Sure. Sounds good, man. So, my background was, always kind of at the interface between hardware and software. The very first thing I used to do was build model rocket controllers for my friends that wanted to launch fireworks and do a whole bunch of random stuff. This was when I was 14. I started my first business building custom PCs for people when I was 16. And then in Princeton, I always focused on robotics and, as I said earlier, the intersection between hardware and software. So doing everything from low-level protocols to, building complicated systems. I was, always participating in hackathons. That was a big thing that I loved doing. But, I was class of 2015, but I dropped out in Princeton from 2014 to go work at a healthcare analytics startup. Ultimately, I found that building an expensive SaaS product wasn't necessarily the thing that I wanted to do with my time. Instead of what I wanted to do was work on technology that was a little bit more, I call it meat and potatoes. Who knows if that's what it's actually called, but something that was a little bit more relatable to the average household. And so I ended up participating in a project at Facebook to do essentially a close range data sharing device. So the idea was like a cell phone case that had its own wireless module. So the idea is that if, I was hanging out with you and you had good T-Mobile service and I had bad Verizon service, I could borrow some of your data and compensate you with crypto for that. So I quickly fell in love with this idea of like how people can team up to overcome connectivity shortcomings. And I soon realized that connectivity is obviously a problem that it faces, all across the world. But what I wanted to focus on was the way that you can make the biggest impact with connectivity. And in my mind, the answer to that wasn't necessarily on the mobility. It was on this other category of, called fixed services, which is pretty much an internet connection that doesn't typically move. So, most common fixed services are like home and business internet, right? Verizon, Fios, Xfinity, right? Those are the things that are typically fixed services. And so what I kind of quickly discovered from that point on is wireless was coming a long way for fixed services. When I looked at like some of the pioneering work of a company like Rise Broadband, which has built essentially a business providing internet in rural America by just renting spaces on top of big TV broadcasting towers and essentially installing dishes on people's roofs, like up to multiple miles of range. And it was a great connectivity solution. And what I was beginning to notice at that time was that technology that was pioneered in rural America was beginning to make its way towards the urban settings and become more and more cost effective. Ever since like 802.11 AC technology, now up to millimeter wave, the technology has come a long way in terms of like raw performance and also mainly in terms of cost. So I guess the kind of, end to my story here is I ended up realizing that if you could team up with people that have excess connectivity and people that have good real estate coverage, you can essentially find a way to take excess capacity and bring it to people that have bad solutions for capacity. So we ended up teaming up with my former university to actually build a wireless ring across their campus and then start bridging that off to the surrounding area. And, that's exactly what we did. And that was kind of the start of our Web2 business, right? We knew that there was a blockchain piece in the works of it. The timing wasn't right. And we can kind of get to like what made me realize that the timing was right now. But we essentially ended up building off a wireless ring off of the campus and then broadcasting out to the surrounding area, and then focused on building a user experience inside multifamily buildings that would allow us to scale that network. And so since then, we've scaled a wireless network from Princeton, New Jersey as our first market to now 10 different states. And we're providing internet coverage to around 10,000 households, so 10,000 active users on the system. So yeah, it's been kind of like this interesting thing of, I had a cool background working on some electronics and robotics, and I was able to kind of fall in love with the networking and wireless side of stuff. And, now as we look at, the future for what Dawn is, and we'll get into that shortly, I think it kind of jives quite nicely. And we have a really cool vision for, I think, how we can bring wireless connectivity to everybody as a means to really disintermediate the central providers. So hopefully that's a kind of like a good quick overview about my background.
No, it's an amazing. I appreciate the in-depth answer. I think for me, it's just damn impressive of what you guys have built thus far. I mean, nearing, or you said around 10,000 houses already connected, having internet connections that are generally much cheaper than the alternatives would be. And to me, one of the reasons why I got so excited about more holistically this category of decentralized physical infrastructure networks was that if you remove crypto, it still works. It may be a little bit harder to coordinate. It may be more friction within that, but there is a product at the end of the day that's providing very clear value. And crypto, essentially the coordination tool that allows everybody to really come together, allow that network to move quicker, and the coordination tool behind it. And I think it's been interesting to me just seeing some of these decentralized physical infrastructure projects more broadly, kind of like almost reject some of the coordination tools, or just realize that potentially crypto may have that extra sauce that they needed to scale to larger communities and more broadly.
Yeah, and I can speak to that because I think that's what you've described as a thesis that I've long had. And I think decentralized physical infrastructure networks, or this category of DPIN, is a very fascinating one because ultimately it just speaks to a trend that we've already seen happen in the Web 2 ecosystem. So I guess the parts that I can kind of speak to at least are on the internet infrastructure, namely cloud and telecom side of things. And this entire initiative of I think what everybody in the DPIN ecosystem believes is there's kind of this shared vision. And the shared vision is what's the end state of DPIN? And in my mind, the end state of DPIN is essentially allowing the end household or end user to provide a meaningful contribution to cloud plus telecom infrastructure, right? Whether it's, compute, storage, bandwidth, right? This is what, the escape velocity folks are always talking about will be commoditized in the future. The end state that everybody in the DPIN ecosystem is pushing towards is one where those resources are actually controlled and provided by the end user in the household. And you've seen that entire transition, which has already existed in the Web 2 space, happen one way or another. The best example is if you look at in Rakuten, for example, and as a mobile carrier is looking at doing miniature data centers at their tower sites. Or whether it's, looking at the initial vision of Filecoin, for example, right? It's just kind of moving these resources more towards the edge because it's just cheaper to have the resources at the edge. There is this inevitability that from a cost perspective, that these resources are going to go from consolidated footprints to more disaggregated footprints. And the kind of main reason why I can point to is if you look at the cost per square footage of buying a data center versus a multifamily apartment building, the cost per square foot for a data center is $180 per square feet, but a multifamily apartment building is $1 to $3 per square foot. So physically hosting this infrastructure that powers the internet as we know it, it's inevitable that it's going to go from a more expensive footprint to a cheaper footprint. So to your point, Logan, about all of this is it's a trend that we all kind of agree on what the same vision is. How we get there might be a couple of disagreements on that, but we all see how it's inevitable and why it's inevitable. And I think the part that really exemplifies how to really accelerate this entire trend, but also to solve a lot of different problems that come from disaggregation is ultimately the blockchain piece of it, to really form a trustless layer on it. So I couldn't be more aligned with you on a core vision here. And, I hope everybody that's listening that kind of starts to think and ask, what is this DPIN space and what does it look like? Keep that end vision in mind about this is a way in which the cloud plus telecom, right, the internet as we know it, can be owned and controlled by the end users, and they can provide their excess surplus to a whole greater ecosystem. So hopefully that's helpful for you guys.
Yeah, 100%. Maybe to start off the conversation, I think it would be helpful to maybe talk a little bit about the product side first and talk about how Andrena and Don are able to really provide kind of internet at a cheaper rate than I would say the historical providers, where that kind of arbitrage lies within the data center, how you guys are doing the last mile, and then transition from what is actually delivered from the product side to the end consumer to more of the technical aspects and how that ultimately all comes together. Because I really want people to understand the holistic product vision of what you guys are trying to achieve and the technology that you've built in-house combined with kind of that crypto coordination tools.
Yeah, so let me actually just give a quick overview on both sides of the thing of the business, so that folks can kind of really understand what each piece is. So I'm the CEO of Andrena. So Andrena is an upstart disruptor wireless and fiber internet service provider. So we essentially go to data centers, we buy a bunch of capacity, and then we work with property owners to bring connectivity to their residents. That's kind of our core Web 2 business that we've been doing for a while now. That's the one that we've got to the 10,000 households across 10 states. The Web 3 side of stuff is this protocol that we've created called DAWN, which essentially stands for Decentralized Autonomous Wireless Networks. And DAWN is a protocol that uses some of the IP that we have built at Andrena to allow anybody to grow the network with us. The underlying vision of it is essentially to create a protocol for providing decentralized broadband. So rather than working with somebody like an Andrena, you can actually get it from anybody that has excess bandwidth to share in their surrounding area. And the easiest mental model I can give to folks is think about it from the perspective of what Helium has done to mobile service, right? Helium provides decentralized mobile service. What Dawn will do is provide decentralized fixed service, so internet for your home or for your business. And so there's a lot of fun things that we can kind of get into that, but ultimately that's the future that we believe in, is that you don't need to buy internet service from a centralized provider like Verizon or Comcast. You can seamlessly buy it from your community that has excess capacity to hand out to folks. So that is kind of the overview about, what Andrena is, and then Dawn. But, Logan, you got a question?
Can you speak to specifically like kind of what you have, the arbitrage with going to the data centers, getting the backhaul, how that's structurally cheaper, and then also talk about on the Dawn side, how you can just essentially share your internet access or access capacities with others around you? Because that arbitrage, I think a lot of people don't really understand, and it's something that I really want the listeners to get have more knowledge around.
Yeah, so integral to both sides on the Web 2 and Web 3 side is what Logan's pointing out here, which is the idea of like you buy internet at one location that is very cheap and you find a way to move it to another location that is historically been more expensive. So the way that looks is at a data center side is where internet is historically incredibly cheap. So, there's a bunch of people, if you think about like the internet supply chain, the way that I kind of think about it is there's 3 different tiers, tier 1, tier 2, and tier 3. The tier 3 internet providers are like Comcast and Verizon, right? The guys that we buy internet service from. The tier 1s are think subsea fiber optic cables, people that just interconnect continents and provide that connectivity. And then on the tier 2 side, this is where essentially this arbitrage opportunity happens. It's the guys who make a business model out of essentially interconnecting data centers. And there's a whole couple of different categories, from internet exchanges to wholesale IP transit providers. But the main thing for the viewers to know is that tier 2 internet providers, you can buy a whole bunch of data for incredibly cheap. Like the easiest way to kind of give that comparison is your home internet bill. Like at my home, I pay $120 for my Verizon gigabit connection. At a data center side, you can buy that capacity for as low as 40 or 50 cents. Like that's really where the magic happens. And this price spread is why internet providers exist in the first place, is that wholesale tier 2 internet transit is just so damn cheap. And you just need to find a cost-effective way to take it from point A to point B. And the reason why they're so expensive, at least on the fiber side, like why am I paying under $20? Is because it costs thousands, if not tens of thousands of dollars to run fiber from that data center towards my apartment, right? That is why you need to have that price spread be so much so that, these internet providers can recoup their investment on their CapEx spend. Where we and how Andrena has fit into this is our approach was, what if we could beam internet from the rooftop of a data center towards a surrounding apartment building? And then I can avoid the entire massive cost of running fiber down the streets. It's just this one-time, very cheap expense, less than $1,000 for a wireless link that can do multi-gigabit capacity. That's really where things begin to get unlocked. And so what everything hinges on, I guess, on the Andrena side and on the Dawn side, is that effective arbitrage, is being able to leverage places where internet is incredibly cheap. And as we think towards the protocol, providing a user incentivized way where people can own that own infrastructure and contribute a little bit to take it from point A to point B so that people can get those entire economics. Like the dream of what I have for all of this is like, how do we bring those wholesale internet prices towards the retail environment? Like I want a world where people aren't paying $120 for gigabit internet. They're paying $10 or $20 for gigabit internet. And in a user-powered system like this, thanks to wireless being so cheap, is what really allows something like this to happen. So that arbitrage is kind of the nuance of how something like this is even possible.
Yeah, when I started to dive into this and understand just exactly how cheap the data center internet really was, and the technology that really you guys have enabled, combined when you can kind of throw some crypto magic for the coordination, there's really something special there. And I think people really do not understand how expensive that last mile really is to hook up the data center to either residential or houses, apartments. It's fairly expensive. And I think like maybe the crude but directionally correct analogy here is going from like dial-up internet to, or not dial-up internet, but more kind of like landline phones to wireless service. And the kind of emerging nations are just able to leapfrog what we've previously had in the United States with no lines and go directly to wireless cell phone plans. And I think here, whether it's emerging or kind of residential, the opportunity is also within that spread. You can be able to enable cheaper internet more broadly for millions, hundreds of millions of people.
Yeah, and that's the if you look at sort of like what are the really successful models in wireless that have created this trend, it essentially flips the way that the CapEx model is structured. So like to Logan's point here, like when he's talking about like why the last mile is so expensive, for anybody that wants to kind of like understand the bread and butter of TMT or telecom analysis here, is there's two real metrics to understand. It's like what's the cost to pass a home? So imagine like running fiber down to your street, and what's the cost to activate your home? And that's just like physically taking that connection from the street and plugging it into your home. The traditional models that we know of the internet are very high on the cost to pass a home. So in order to create a lot of coverage, it's very expensive, but the cost to activate the home is much lower, on the order of literally less than $1,000, probably a couple $100. The most successful wireless models that we have seen that have taken us from this sort of like cable infrastructure to wireless infrastructure have inverted that capital model. And so a good example of that is 4G LTE and now 5G, and we can talk about a whole bunch of stuff on 5G. But the point being is they have found that you can actually spend a little bit good chunk of money on a centralized transmitter that gives you, in terms of households passed, a huge bunch of coverage. And then on the flip side, it might be a little bit more expensive to activate the home, but you really get to create a lot of momentum by creating a wireless coverage. And that, in my mind, is what the promise of wireless can achieve, is just flipping that capital model to allow businesses to scale much faster. Because once you get that coverage, that is really when these sorts of initiatives can really take off the ground. And one really good and classical example of this is something like Starlink, right? Like if you look at the raw coverage of Starlink, like for them, I got to double check the exact numbers, but we're talking like tens of dollars to pass a home, even though it costs billions to put that constellation in space, right? The underlying cost is spread out over so many different households. And that is really the magic of wireless here is you take that cost structure that is typically known and you completely flip it on its head, such that the cost of creating coverage is so low, but then the cost of actually activating a user once you each actually have that revenue is a little bit higher, but that's okay because the revenue is going to be coming in. And that is just a more efficient way of doing telecom, right? Is your customer acquisition cost is just lower from the upfront side of stuff. And then you actually have more confidence in being able to service people. So there's a lot of fun things that we can chat about that. But that, in my mind, is like the two most successful wireless models, right? Mobility and now something like LEO and Starlink. And they have demonstrated unit economics like that make wireless successful. And as we look at what Dawn is capable of doing, it's very similar in that sort of model where people are owning their own base stations and creating a lot of coverage. Like we're talking like coverage for $10 to $15 per household. And then it's also very cheap for somebody else on the downstream to get set up. So I'd say those are, not to repeat myself too much, but those are the successful wireless models that I really like.
No, I think it should be repeated because I think this is not fairly widely understood about how disruptive this can be. And I think it warrants kind of double clicking on really how massive this arbitrage is. And it wasn't until recently that the technology really just became possible to do this. But before jumping maybe into some of the more technical nuance, can you dive slightly deeper into the Dawn side as well, and how that's ultimately can be used at kind of like the home internet sharing perspective, and maybe even dive into for what you can share on the hardware side?
Yeah, I'll cover all of that. So to give you guys a sense on the Dawn piece, so as I kind of started off, right, Dawn is a protocol for providing decentralized broadband. And the best mental model that, if you're a listener that I want to kind of keep with you here, is think about Dawn very similar to what solar panels did to electricity, right? We see a model to do the same thing with Dawn, except for internet. And the way that essentially solar, kind of democratized, I guess, access to power where anybody can just get their own power, it's very similar with Dawn. The same way that in the case of solar, you own your own infrastructure. You don't have to depend on any carrier to generate your own power. But then it gives you access to a very cheap resource, and you can even sell your excess capacity back to the grid. Right. This is functionally very similar from the Dawn perspective, where users own their own node. They'll get access to a very cheap resource, and whatever they don't use, they can sell that back to the surrounding grid. The nature and why the blockchain is even necessary in this sort of scenario is unlike in the case of solar, you don't need to collaborate, right? I can just put up solar panels and I can just grab power for my own use. But in the case of wireless coverage, a single wireless link, in the best case scenario, maybe less than 5 miles worth of range, you need to kind of create these hops of wireless connections to create a mesh in a given area. And that problem of that is that inherently relies on collaboration. And so what the blockchain piece does is that allows us to actually add a trustless layer where I don't need to trust somebody else on what resources that they have to know the underlying state of the network. And so the biggest kind of first piece of the technology here is the same way blockchains, people talk about network consensus. They achieve network consensus. The way that we use them is to build wireless network consensus. So essentially to achieve that, there's 3 major proofs that we have here. We have proof of backhaul, which essentially is you can think of it like a decentralized speed test. It allows us to know in a trustless way what is the capacity, what is the amount of supply a node has. Number 2 is proof of location. So we actually know where an individual node is, and where telecom resources are is an important metric, right? We can't be giving people wireless devices to connect to if nodes are way too far away. And then the third piece of this is actually proof of frequency. Is in any large scale wireless network, there's a limited amount of spectrum. And the FCC and the rest of the world is releasing a lot of spectrum right now, thanks to 6 gigahertz. So there's a huge opportunity for us to be able to leverage that. But the point being is you need a communication layer that really allows and make sure that people don't step on each other's toes. It's the same way that the FCC goes out and auctions spectrum to Verizon, like in 3.7 gigahertz, or in T-Mobile to 2.5 gigahertz. You need some level of a coordination layer that holds people honest to use the frequencies that are actually allocated towards them. So those are really kind of the core pieces of it from the blockchain side of stuff, right? We need to find a way to develop wireless network consensus. And then we need to have a way in which we can hold people accountable towards all of that so that people can operate in a trustless fashion. So that's kind of a good quick primer on sort of how all that fits in together.
Do we want to touch upon the spectrum piece and what hardware you guys kind of enabled as the next jumping off point?
Yeah, let's get right into that. So from the spectrum piece to understand here is every time there is a new allocation of spectrum for operators to build cool networks with, and vendors to build new technology, it leads to a huge economic transition, right? And the most famous one that we're all familiar with is probably the public release of 2.4 gigahertz and 5 gigahertz, which essentially led to the creation of Wi-Fi and Bluetooth. Think about how many ecosystems were built because of the creation of Wi-Fi and Bluetooth. And the latest one, or I guess the second latest one that was really of note here, was on CBRS, which was 3.5 gigahertz. And CBRS was essentially how a company like Helium built their entire network. They said, great, we have the spectrum available to build a very cool wireless product for mobility applications. So now we can take this and go apply this to this area. The part that we are leveraging now is this category of for fixed wireless, which is 2 major categories here. It's the millimeter wave and microwave. The millimeter wave, think very short wavelengths, very high in the frequency, so 60 to 80 gigahertz. And that stuff started really becoming mainstream in 2019 up to 2023. And then that final piece of this is on the microwave side, which is 6 gigahertz. So the FCC essentially to Wi-Fi 6E is the whole category. They released 1.2 gigahertz of 6 gig spectrum. So I believe 5.9 to 7.1 gigahertz. And the rest of the world has followed suit. They split it up in different ways, but this is kind of the next frontier, right? Is we now have a whole chunk of spectrum, even more than what was released when Wi-Fi was created. So now that we have all this new spectrum to do a bunch of cool connectivity applications on, we've been keeping our eyes peeled for what are vendors building on here? And the category which really enables both Andrena and Dawn is this category of wireless called point to multipoint fixed wireless. And point to multipoint fixed wireless, that also happens to be multi-gigabit. So what that means is you essentially have one node that can talk to many other nodes and provide multi-gigabit fashion. That technology first started hitting the market mainstream 2022, 2023 for 60 gigahertz and beyond, 60 to 80 gigahertz. But 6 gigahertz just started getting released. Vendors, like Tirana and Cambium just started getting approved less than 2 months ago. So we're in a scenario that, in my mind, is going to be a golden age for wireless and terrestrial applications, because we finally have that major threshold of point to multipoint and multi-gigabit. And those are really the two things that you need to be able to actually replace the existing solutions that are fiber that are out there. Because historically, we had point-to-point solutions, so two radios kind of pointed at each other that could do multi-gigabit. That stuff ended up being very expensive, but it's also not scalable, right? If you need to put up a new antenna for every single customer, it doesn't really scale that well. But the fact that we have sort of this gold standard of gigabit functionality with one node can talk to many, that is really the major unlock that we have, and we as an industry have to take advantage of here. And what we have done on the Andrena side to go on top of that is, one of our core pieces of IP is we built something that we call the ROS, which stands for the Robotic Antenna System. And the way that you can think about it is essentially like a downstream antenna from a centralized transmitter that can actually aim and align itself. Like, one of the trickiest parts of deploying your own fixed wireless gear is going through the process of aiming and optimization, right? Sometimes you have to deal with reflection. Sometimes you have to deal with interference. There's a lot of different things. And our thesis was, could we build something for both our own operations, but also now usable for everybody else, that allows that to seamlessly and automatically align itself to be able to be both, good for initial setup, but something that also allows it to heal, right? So if you deploy one of these nodes, you can point at one signal source, but if a better connection opportunity springs up from the community, it can now point itself to a completely different signal source. And that, in my mind, is really the power of this ROS solution, is it helps add the A in DAWN, right? Decentralized autonomous wireless networks. It helps make it autonomous. And that is a really core piece of it.
It's kind of like what SpaceX is doing with Starlink, isn't it?
Exactly.
Very similar, technologies.
Exactly. And that was, I can't say that was an inspiration. We were working on this technology before they went to market for it, but they beat us to market. Yeah, they beat us to market for it. So they get a lot of credit for that, obviously. But yeah, in the case of like a Starlink type installation, you install a dish on top of your roof. And there's actually a slew drive mechanism in there that actually points it at the constellation. And then they have their own phased array, which does even tighter beamforming. But the point being is, like, this technology is necessary because directionality in wireless is one of the major things that we need to leverage that multi-gigabit functionality. We can't just have omnidirectional antennas that don't form a beam. They need to direct the beams in very tight paths. And that is really where a mechatronic type system comes into play. In the long run, over the future, there would probably be like what's called electrical beam steering, which essentially uses a very complicated patch antenna to beam that signal without any moving parts. But the industry is not there yet. It's too expensive to implement those types of solutions. So what we've opted for is essentially a robotic antenna system. So that is, I think, a very cool system that we haven't seen out there in the market. You've seen them in the case of satellite, for example, but in this case of terrestrial, we haven't seen anything like that. And again, it's what allows this network to be entirely autonomous so that an end user doesn't have to be a wireless expert to be able to help set up an individual node. And that's a key piece for this, is to be able to be simple for the user, but also allow it to heal and readjust itself on the fly.
Yeah, I hope all the listeners are really kind of like dialed in, because it's really, as you've kind of been pointing out through all this, whether on the technical side from the technology with the multi-beam at gigabit speeds, being able to have the relationships with the data centers by the backhaul, create these proof of observes, the coordination tools on the blockchain side, and even from the blockchain architecture design, those just now hitting levels of scale that can actually support a system like this that's cost and efficient to help on the coordination side. Really, all the pieces are coming together, where ultimately what it is unlocking is this arbitrage between the data center that is really extremely cheap internet access and really cutting out the last mile that historically was the most expensive and making it essentially more widely available through especially some of these hardware technologies that you guys have also helped build. Can you talk a little bit more just about the hardware, both from like the multi-beam and kind of the residential kind of customer facing side, and how those kind of intertwine with the network as well?
Yeah, so there's three major pieces of what we have built at Andrena that is IP that is now going to be relevant inside Dawn. The first one is that robotic antenna system. So as a refresher, it's an antenna that can point and aim itself to whatever the signal source is. So the idea is that you can have an automated deployment and then a self-healing network. The second piece of it is we actually went down the route of building our own Wi-Fi system. So whenever you bring connection to a building, the most cost-effective way to propagate that connection throughout a building, whether it's a commercial building, a multifamily building, is using the latest in Wi-Fi technology, Wi-Fi 6, Wi-Fi 6E, and now Wi-Fi 7. So we've manufactured our own PCBs with custom antennas to be well suited for that environment. So the idea of somebody who's like, say, running like a 4-unit Airbnb, they get a Dawn connection to their building and they can actually use this really cheap Wi-Fi system. We're talking, way less than $100 per device. But then the idea is it creates what's called an FDD mesh throughout the entire building. So it's a frequency division based mesh throughout the entire building. So you essentially have really good frequency reuse so that you can essentially have high speeds throughout the entire area. That was one where we've seen a big lift from working with our landlord partners. It provides better performance. It's cheaper for us. And now you can actually provide those types of solutions in your own unit, your own apartment building, whatever it is. The point being is like the last couple 100 feet is really where something like this comes into play. It allows you to get your Dawn backhaul connection and then propagate it throughout your building, throughout your apartment very cost effectively, and also share that with other people in the surrounding area. So that entire system is one that really leverages to that. And again, it just gives you good coverage for yourself, but it allows you to share that with anybody in your vicinity. That's the second piece of it. The third core piece of this one is one that's very special to me. And it's one that I think aligns and resonates quite nicely with that DPIN vision that we were speaking to earlier. So what we have built, and I'll give the quick overview before I get into the pretense of it. What we've built is essentially a software router. So the underlying thesis and vision behind it is, I always say, like, what if every single Verizon or Comcast router / modem was replaced by a high performance server, right? Your router that sits in your home to provide your internet connection is just providing, it's just doing internet, but it is an active piece of electronics that has a lot of potential. And so in my mind, if that was replaced by a high performance server, now you have taken a massive step towards achieving this decentralized vision where the actual household is participating in the overall cloud. And so thanks to some technology that was released by Cisco, namely VPP, called vector packet processing, it allows you to essentially do and create a software-based router on a generic purpose computer. And that is really the special thing here. So we've built our own software router that operates this entire network that sits on a generic purpose computer. And the idea behind it is, again, as I kind of alluded to earlier, is not only is your router going to be giving you a cheaper source of internet through Dawn, but it's going to be able to participate in any decentralized DPIN project that's out there that actually participates in helping cloud infrastructure. So whether it's something like IONet or Akash and you want to do something on the GPU side, whether you want to do something on the storage side with Filecoin, now your individual household can participate in this greater ecosystem. And so our vision for all of this is we want cheap internet to essentially be, a little tongue in cheek, kind of like a Trojan horse for getting this high powered infrastructure into people's households. So that allows you to actually participate in this greater ecosystem. And one of the kind of like key things for all of DPIN is like, what is that killer app? What is that killer use case that helps bring this entire Web3 ecosystem and expand it to everybody? And our belief is cheap internet is going to be that case, right? What is more relatable than a cheaper source of internet, right? Everybody in the world uses it. So if you can find a way to use that cheap internet to then bring an additional platform where the entire cloud now becomes a part of everyone's home, then you've taken a massive step forward towards this entire DPIN vision. And so I'm really excited for that, by that entire thing that we're building. And the software router is one piece where we kind of say, hey, if we can kind of do two birds with one stone in the form of a software router, let's do it, because now there is going to be so much more equity value in the individual household now that it's participating in the entire cloud infrastructure itself.